Let's find the area of the region bounded by the graph of the parabola y equals to x squared. Its tangent line, so the tangent line to the graph of y equals to x squared at the point of tangency 1, 1, and also the x-axis. So we can actually sketch this region now without knowing the exact equation for the tangent line. Then we can find the equation without too much difficulty. This is the graph of the parabola y equals x squared. Let's say this is a point 1, 1. The tangent line goes down like that, and along with the x-axis you can see that the region in question is right there. So we want to find the area of that region, but first we have to find the exact equation of the tangent line. Recall that if f of x is x squared, when we take its derivative we end up with 2x, and then plugging in the x-coordinate of the point of tangency into the derivative, so plugging in 1 into the derivative, we end up with 2, and that happens to be the slope of the tangent line. So now putting that together, we have a point 1, 1, the slope is 2. Y minus 1 is equal to 2 times x minus 1. So y minus 1 equals to 2x minus 2. And therefore the equation of the line is y equals to 2x minus 1. Let's bring everything together, sketch this region once again. So this is what it looks like. This time I'm just going to sketch the right half of the parabola. We do not need the entire parabola, just the right half of it. So let's put it in here like this. This is the point 1, 1, and the line comes down like this. We're going to need this x-coordinate here. It happens to be 1. And then we also are going to need this point. That's when the line intersects the x-axis. So the line is, of course, 2x minus 1. We put in 0 for y. That gives us 0 equals 2x minus 1. 2x equals 1. X equals to 1/2. So this is a point 1/2. And now that's the parabola y equals x squared. And that's the line y equal to 2x minus 1. If we're going to integrate with respect to x, we're going to need two integrals, one for part 1 of the region and one for part 2 of the region. The area of this region then equals to first the integral from 0 to 1/2. X-axis is below, x squared is above, so it's just the integral of x squared plus the second part will be integrating from 1/2 to 1, and x squared is above and the line 2x minus 1 is below. Be sure to put the line in parentheses when you're subtracting. If you don't, then you're going to make a mistake with that minus 1. Now let's simplify this. The integrals are from 0 to 1/2 x squared dx plus the integral from 1/2 to 1 x squared minus 2x, and it's going to be plus 1. If you don't include parentheses, you'll have minus 1 and make a mistake. So this is now very easy integrals. Everybody should be able to clearly and easily integrate it. We have 1/3 x cubed evaluated from 0 to 1/2 plus 1/3 x cubed minus x squared plus x, and that's evaluated from 1/2 to 1. So plugging in 1/2 into the first part, 1/2 cubed is 1/8 times 1/3 is 1 over 24. Plugging in 0 yields 0. Next we're going to put 1 into the second part. We have 1/3 minus 1 plus 1. Here these cancel. Minus, putting in 1/2, once again we have 1 over 24 minus 1 over 4 plus 1 over 2. So let's go ahead and simplify this, have a common denominator of 24. We have 1 over 24 plus 1/3, that's 8 over 24, minus 1 over 24 minus 6 over 24 plus 12 over 24. Now together this part over here, that's minus 5 over 24 plus 12 over 24. That is 7 over 24. And so we have 9 over 24 minus 7 over 24, which is 2 over 24. The final answer is 1 over 12. The area of this region is equal to 1 over 12. While we're doing this problem, let's go ahead and find the area using a different method, namely integrating with respect to variable y. So I'm going to redraw it. This is the parabola, and this is the line. That's the point 1, 1. So the y coordinate here is 1. If I take y equals to x squared and solve this for x, it's actually plus or minus square root of y, but because we are in the first quadrant, x will be plus square root of y. We take the line y equals to 2x minus 1 and solve that for x. Y plus 1 equals to 2x, so x equals to 1/2 y plus 1/2. So this right here, solving for x, that's square root of y. The line is x equal to 1/2 y plus 1/2. If we now pick a typical y and look at this horizontal strip, we enter through the parabola, we exit through the line, so the area can now be evaluated using one and not two integrals. It's the integral from 0 to 1, the exit part, which is the line 1/2 y plus 1/2, minus the entry part, which is square root of y. Let me write it as y to the 1/2, and then integrate that, of course, with respect to y. So this is equal to 1/4 y squared plus 1/2 y. The integral of y to the 1/2 is minus 2/3 y to the 3/2. And we're going to evaluate this from 0 to 1. So this is 1/4 plus 1/2 minus 2/3. 1/4, that's 3 over 12 plus 6 over 12 minus 8 over 12. So 9 over 12 minus 8 over 12. We end up with the same answer, which is 1 over 12, which is the area. For more videos, visit www.mathprepvideos.com.